Hello programmers! We are going to continue our discussion on function templates. Function templates, or generic programming, allows you to have a placeholder for the data type for one or more of your input arguments to a function, or even the return value from a function. So here I've got a function named repeat value, and this takes two arguments in parentheses. One we know in advance has to be an integer, or you have to be able to convert it to an integer. And the other, we have a placeholder saying we don't know in advance what the data type is going to be. This is a function template, so our very first line right before the function says template. We're going to have a generic data type. We'll use capital X as the placeholder for that data type. So at runtime, this capital X could be replaced with an integer, or a string, or char, or whatever it is that the user passes in as their first argument to the function. And so we're passing in the second argument. We know in advance that's going to be an int. There's no other interpretation for that. It's not a generic data type. Based on this times, the int that they pass in, we're going to go through a for loop that many times, print out whether it's the first, second, third, whatever time through the for loop it is, and then we're going to take that first argument to the function and pass it to the insertion operator. So print it to the output stream. I call the function two times in main. The first time I call the function, I'm passing in, and if I hover over this hello in Visual Studio, it tells me the data type. It's a constant character array. There's 6 different characters, so it looks like 5, but we've got a null character at the end. So we've got a constant character array. We're going to pass that to our function, and so the compiler will know implicitly by looking at that constant character array that X really should be a constant character array. And the number 3 is going to be passed into the variable times. So we'll repeat the word hello and print it to the screen 3 times, so time 1, 2, and 3. And then we call repeat values again and pass in an int, number 67, and we say we want to print that to the screen 2 times. Alright, so in both of these calls to repeat values, the compiler is implicitly figuring out, just by looking at the data you're passing in, what X should be for each of those function calls. But there's another thing that we could do. We could explicitly tell the compiler what to do with the first input argument. So we can put in the type name. So right here, this is an integer. So I'm explicitly saying that this repeat value, what's in the angled brackets here, this placeholder X, should be int. So that's just another way of saying that this should be an int. If I run this, there's not going to be any difference because it was implicitly figuring out it was an int before, and now we're just explicitly saying this is an int. So no difference when we run the program. But there's a reason I picked 67. If you look on the ASCII chart, 67 is actually a printable character. So what if I, instead of treating this X as an int, what if I say treat it as a char? Well, now we're actually going to see a difference. The compiler is going to create a version of repeat values where X is replaced with char, and int stays the same because it's not a generic type, and we will find out that in the ASCII chart, 67 is capital C. So we're going to print capital C 2 times. So this was a way to tell the compiler what data type we wanted X to be. All right, I want to show a little example of how these function templates can work not only with just ints and chars and primitive data types, but a data type we make up ourselves. So let's say we have a class bunny. So Easter's coming up next month, and let's say that this bunny has a name and the number of Easter eggs it has. The constructor is just going to say the bunny is always named Peter Rabbit, and it always has 365 Easter eggs, I guess 1 for every day of the year. And then we've also got a friend function, and our friend function is an overloaded insertion operator. So it tells us what does it mean to send a bunny object to the insertion operator to print it to cout or to a file. Well, it means that you're just going to print the bunny's name and the number of Easter eggs. All right, so I've created my own user-defined data type called bunny. Can I use it with this function template? And the answer is going to be yes, because the function template just needs to know how to use the insertion operator with that data type, and we've overloaded the insertion operator here. So in main, I can just create a bunny object. So I'm going to say this is the Easter bunny. And then I can call repeat value and pass in the Easter bunny and how many times I want to repeat that function where I'm passing in that bunny to the insertion operator. And then we'll find out that repeat values works not only on primitive data types, but on data types that we make ourselves. So I can see I'm going through the function 4 times and printing out the information about that bunny object.